Advances in rotary technology for wire EDM and the software to run that technology have been accelerating in recent years. These developments in rotary wire EDM open up exciting new opportunities for cutting complex shapes unattended, cost-effectively, and precisely in one setup. With spin and burn, the workpiece spins around the rotary axis while the wire cuts a two-axis profile. Small, dynamically balanced parts that require a high surface quality can be cut with high-speed erosive turning. The absence of tool pressure allows for minimal diameters. The first step is to perform rough turning. Since the material used for EDM turning operations is typically expensive, the initial roughing operation is designed to remove the stock material in pieces large enough to allow for easy recovery and recycling of the unused material. The rough turning operation includes multiple indexing moves to remove as much material as possible before the finishing cut, and after the rough indexing moves are complete, the shape should be close to the final shape before finish turning begins. A finish EDM turning operation is then performed, and it is similar to a lathe contouring operation with the added benefit that no tool pressure is applied to the workpiece. With an indexing operation, the rotary axis is used for positioning between each machining cycle. Whenever a rotary move is required, the part is rotated and locked into position before cutting starts. The part is always held stationary during the cutting process. This process is simple because the operations are created like any other two-axis EDM operation, except that a positioning move is added between them. It is important to note that small, delicate parts cannot be cut efficiently and with high quality using traditional mechanical milling or turning methods. EDM is the perfect solution for cutting delicate parts since there are no cutting forces involved. It is even more advantageous when dealing with difficult-to-cut materials such as titanium, Inconel, or Hastelloys. These materials are very tough and springy, so when mechanical processes are used to cut them, chatter is a huge problem, causing high tool wear, poor surface finish, and broken workpieces. With synchronized rotation, the workpiece is rotated during the burn. The turn-while-burn process synchronizes rotary motion of the part with X-Y-U-V movement of the wire. As viewed in this example, the rotation of the part is synchronized with the rectangular axis movement. Turn-while-burn greatly increases the flexibility and the complexity of the shapes that can be cut. This process is also useful for extreme tapers that cannot be cut with traditional wire EDM. For many manufacturers, there is great potential for adding Rotary Axis EDM technology to their current capabilities. In many cases, it is a better alternative to machining processes that use traditional tooling.